Alright, so in this video I'm going to go over the 2024 AP Computer Science A free response questions. Now, a bit of a disclaimer is that I have not actually seen these questions. So I don't know what they are, and we're going to be going through them together, and hopefully I'll get them all right on the first try. So I know that, on the exam you write it on paper, but to sort of compensate for that, I don't really want to, I want to make it as authentic as possible without actually having to write, actually having to handwrite code. I just have a text editor open without any syntax highlighting or anything like that, and I won't be compiling the programs until I've done all 4 questions. Okay? So we have an hour and 30 minutes to do this, so I'm just going to have a timer. I don't think it'll take me the full hour and 30 minutes. I hope it doesn't take me the full hour and 30 minutes, but let's see. Alright, let's go. Alright, this question simulates birds or possibly a bear eating at a bird feeder. The following feeder class contains information about how much food is in the bird feeder, and simulates how much food is eaten. You will write 2 methods of the feeder class. Okay, so we have current food in grams. Simulates one day with num birds or possibly a bear at the bird feeder. Returns the number of days birds or a bear found food to eat at the feeder, and the simulation is described in part B. Okay, let's see. Alright, write the simulateOneDay method, which simulates num birds or possibly a bear at the feeder for 1 day. The method determines the amount of food taken from the feeder on this day and updates the current food instance variable. The simulation accounts for normal conditions, which occurs 95% of the time, and abnormal conditions, which occur 5% of the time. Okay? Under normal conditions, the simulation assumes that on any given day, only birds visit the feeder and that each bird at the feeder consumes the same amount of food. The standard amount consumed is between 10 and 50 grams of food, inclusive in 1 gram increments. That is, on any given day, each bird might eat 10, 11, up to 49 or 50 grams of food. The amount of food eaten by each bird on a given day is randomly generated, and each integer from 10 to 50 inclusive has an equal chance of being chosen. For example, a run of the simulation might predict that for a certain day under normal conditions, each bird coming to the feeder will eat 11 grams of food. If 10 birds come to the feeder on that day, then a total of 110 grams of food will be consumed. Okay. If the simulated food consumed is greater than the amount of food in the feeder, the birds empty the feeder, and the amount of food in the feeder at the end of the day is 0. Under abnormal conditions, a bear empties the feeder, and the amount of food in the feeder at the end of the day is 0. Okay, so we have some examples here. Example 1. If the feeder initially contains 500 grams of food, and the call that results in 12 birds eating 20 grams of food each, that leaves 260 grams of food in the bird feeder. Okay, so that would mean that we have 12 times 20, which is 240. Let's see. If the feeder contains 1,000 grams of food, the call simulateOneDay 22 could result in a bear eating all the food, leaving 0 grams of food in the feeder. If the feeder initially contains 100 grams of food and the call results in 5 attempting to eat 30 grams of food each, since the feeder contains less than 50 grams of food, the feeder is emptied, leaving 0 grams of food in the feeder. Okay. Alright, so complete the simulateOneDay method. Okay, so this shouldn't be too bad. So we actually need multiple random numbers to be generated. This is pretty interesting. So public void simulateOneDay int numbers. Okay, so set do you do this in Vim? Whatever, we'll just do this. Okay. Right. So what does it say? It says 95% of the time. So we need a number between, or actually we just need like, so double chance equals math.random. So this variable we'll just call it condition. So we know that math.random returns a number, a floating point number between 0 and 1 exclusive. So if the number is less than or equal to, sorry about the font being messed up, but less than or equal to 0.95, then we say, let's put these in comments. If it's less than or equal to 0.95, then normal conditions. Then otherwise, it's abnormal. Okay? So let's do this. So if condition is less than or equal to 0.95, then that means we know that it's a normal condition. Otherwise, we know that the bear eats all of the food, and this, so to set the instance variable, we have to do this dot current food equals 0, and then we're done. So bear eats all food. All right. So now we want to do if it's a normal, if it's something like if the condition's normal, essentially is what I'm trying to say. So we need to generate a random integer between 10 and 50 inclusive. So of course this just requires you to know how math.random works. I imagine that you could probably use the random class as well, but I'm not 100% sure. I don't have the quick reference guide with me, and I'm just not going to, I'm not going to use that. I'm going to use math.random. Okay, so we know that to generate a number between, let's say an integer between 0 and 9 inclusive, we can just do this. Okay, so that gets us between 0 and 9 inclusive. Okay, so if we want to get it between 1 and 10 inclusive, then we just need to add 1 to this. Okay, and then if we want to get it to between 10 and 50, we can just do add 10 and then multiply it by, let's see, 41, I think. Yes, because that would put it between 0 and 40 inclusive, and then that becomes, well, it's a floating point number between 0 and 41, and then if we cast it to an int, this font is so weird, it becomes 0 to 40, and then if we add 10 to both bounds, we get 10 and 50. Okay, so that's that. So now we just need to say if, so the amount that they ate is numbirds times g. Okay, so if amount 8 is greater than this dot current food, then we say this dot current food is equal to 0. Otherwise, we say this dot current food minus equals amount 8. Okay, that should be it. Okay, all right, let's go to, it doesn't say we have to use anything. Yeah, so I think we're good. Okay, part B. Write the simulateManyDays method. The method uses simulateOneDay to simulate num birds or bear coming to the feeder on at most num days consecutive days. The simulation returns the number of days that birds or a bear found food at the feeder. Okay, so let's see. Okay, so we say simulate one day leaves 2,100 grams of food in the feeder. Then it leaves that, then it leaves that, then it leaves that. Okay, so it's basically just computing how many days result in current food being greater than or equal to 0. Or sorry, greater than 0, not equal to 0. Okay. Complete the simulateDays method. Assume that simulateOneDay works as intended, regardless of what you wrote in part A. Okay. So let's see. Public int simulateManyDays. Int numbirds, int days. So basically, we just want to see let's see. So while this dot current food is greater than 0, so, and we'll just keep a counter. So like int days equals 0. So while the current food is greater than 0, we're going to increment this, and then we're going to simulate one day and pass it num birds. Okay, and then just return 0, return days. Okay, so in this case, so it'd be 1 day, 2 days, 3, 4. And there's only 4 days of the. Well, actually, we need another condition. And days is less than num days. Okay, so we have to have an upper bound on the number of days. So this will keep incrementing, and when either the current food is less than or equal to 0, or days is greater than or equal to num days, that's when. Excuse me. That's when we will break out of the loop. Okay. I'm pretty sure this is. I'm like 99% certain this is correct. Okay. All right. That's problem 1. All right. Let's go to here. All right. Problem 2. This question involves a scoreboard for a game. The game is played between 2 teams who alternate turns so that at any given time, one team is active and the other team is inactive. During a turn, a team makes 1 or more plays. Each play can score 1 or more points and the team's turn continues, or the play can fail, in which case no points are scored and the team's turn ends. The scoreboard class, which you will write, is used to keep track of the score in a game. The scoreboard class contains a constructor and 2 methods. The constructor has 2 parameters. The first parameter is a string containing the name of Team 1, and the second parameter is a string containing the name of Team 2. The game always begins with Team 1 as the active team. The recordPlay method has a single non-negative integer parameter that is equal to the number of points scored on a play, or 0 if the play failed. If the play results in 1 or more points scored, the active team's score is updated and that team remains active. If the value of the parameter is 0, the active team's turn ends and the inactive team becomes the active team. The recordPlay method does not return a value. The getScore method has no parameters. The method returns a string containing information about the current state of the game. The return string begins with the score of Team 1, followed by a hyphen, followed by the score of Team 2, followed by a hyphen, followed by the name of the team that is currently active. Okay, some basic information. Yeah, some sequences, that's fine. So game.recordPlay, Team 1's active. Yeah. Write the complete scoreboard class. Okay. So this one's not too bad. So let's do, I assume everything is public, so, well, except for instance variables, scoreboard. So we need to know well, first off, let's write the skeletons for the constructor. So int t1 name, string t2 name, and we'll fill these in momentarily. And now let's say public void says it does not return a value, so it has to be void. Record play, and then a single non-negative integer parameter. So int points. So a precondition here is that, and of course you don't need java.comments or anything like that, but it just kind of helps. Points is greater than or equal to 0. And if it is 0, then that means that the play is over. Okay, so we actually need a few instance variables. We need a private string t1 name, private string t2 name, private int t1 score, private int t2 score, and then private boolean. Okay, so here's where a design choice has to come into play. We need to be able to swap between who is currently playing. So you could do something like private string active team and then just swap them. And actually, I think that would be a better idea. So let's move that up here. Yeah. So now what do we do in the construct? Well, let's first write the skeleton for the getScore method. So public int getScore, or nope, whoops, returns a string. All right. So we know that it returns a string containing information about the current state of the game. So part of me really wants to use string.format. But because I don't know if that's taught in the AP subset of Java, we'll just do a bunch of concatenation. So we'll come back to that. Okay. So of course, with the scoreboard constructor, we need to do our assignments here. And then we just need to say that the active team is just the first one, and then the scores are initially both 0. Okay. So what we could do, and actually I think I will do this, I'm going to write a helper method that swaps the teams. So private void swap active team. So what this will do is if the current active team is T1, then it becomes T2. If the current active team is Team 2, it becomes Team 1. Okay? So if this dot active team dot equals, remember you have to use dot equals with strings. So if this dot active team dot equals and this dot t1 name, then this, that's way too many spaces, this dot active team equals this dot t2 name. Otherwise, this dot active team equals this dot t1 name. Okay, so of course this branch could actually be executed if this dot active team is equal to literally any other string besides this. But I mean, given the constraints that we have, this will only execute if this dot active team is equal to this dot t2 name. So I mean, we could put a comment here just for clarity. If this dot active team is equal to this dot t2 name. Okay. All right. So now that we have that, we can very, very easily write record play. So what are the conditions? It says if the play results in one or more points scored, so if points is greater than 0, just write the branches like that, then we say the active team's score is updated and that team remains active. Okay, so this is where we actually need to do so it's like, how do we want to, you know, do this? So so there are a couple ways. We could write a method that says, and actually we could do this here. Like, we could write a private boolean is team1 active. And actually, I think I'll do this. So we can just write two methods. Private boolean is team2 active. Return this dot active team dot equals this dot team2 name. And because I'm lazy, we're just gonna copy and paste it. Okay. So now we can just use these methods, or you can just use this dot is team1 active, and down here this would be equal to this dot is team2 active. Okay. So yeah. So now we need to say if this dot is team1 active, in which case we will update team1's instance variable, their score instance variable. Let me be a little bit clearer. So we want to say this dot t1 score plus equals points, and of course they remain active. This dot t2 score plus equals points, and again they remain active. Otherwise, what does it say? If the value of the parameter is 0, the active team's turn ends, and the inactive team becomes the active team. So that means we just need to do this dot swap active team. Okay. So again, you could have just written all this logic, and actually I'll just get rid of this because it doesn't really add anything to the code. Right, so I mean, you could just put all of these lines inside of the recordPlay method, and it would be the same. But, you know, in APCSA and in general, we should try and keep our methods as small as possible, and as simple as possible. Okay? So we have a method that just determines if, like, which team is active, and one to swap the team, and then one to record the play. Okay? Hopefully this will make writing getScore just a little bit easier. So it says it returns a string containing information about the state of the game. It begins with the score of team 1, followed by a hyphen, followed by the score of team 2, followed by a hyphen, followed by the name of the team that is currently active. So, right. So actually this is very straightforward. Come on. What is going on? Okay, ignore that, I guess. Okay, so we want to return this dot t1 score plus a hyphen plus this dot t2 score plus another hyphen plus this dot active team. Okay, so it's line wrapping, but it doesn't really matter. You know, we could do something like this. Yeah. Okay. Yeah, I mean that's it. I don't think getScore should be any more complicated than that. Okay. So we have a little bit over an hour left, and let's just keep going. That's question 2. Let's quit out of that. Problem 3. All right, here we go. This question involves the manipulation and analysis of a list of words. The following word checker class contains an array list of strings to be analyzed and methods that are used to perform the analysis. You will write 2 methods of the word checker class. Okay, contains no element. Returns true if each element of word list, except the first, contains the previous element as a substring, and returns false otherwise as described in part A. Okay, and then we'll come back to part B. Okay. Write the isWordChain method, which determines whether each element of word list, except the first, contains the previous element as a substring. The following table shows 2 sample isWordChain method calls. Okay, so here it returns true because this is a substring of this is a substring of this is a substring of this. Okay, and this one returns false because this is a substring of this is a substring of this, and this is not a substring of this. Okay, so this one, oh, whoa, did not mean to do that. Okay, so this should be very straightforward, but I imagine that a lot of people could get this wrong because they don't know. It says to do every word except the first, of course, because there's no way that anything before this can be. There's nothing here. I mean, if you interpret it as the empty string, then absolutely, it would still trivially work because the empty string is a substring of every string. Okay. But the most straightforward way to do this is just to have a for loop that starts at 1 and not 0, and it goes up to the size of the word list. And then let's just have 2 variables called string prev equals this dot word list dot get I minus 1, and we know this will never go out of bounds because of the bounds of the for loop. String cur is equal to this dot word list dot get I. And now we want to have an exit condition. So what is the exit condition? Well, the exit condition, or what happens when it's false, is when previous is not a substring of this. Okay? So that means that we can use the dot contains method, or we could also use index of. I'm not sure if dot contains is in the AP subset, but I'm just going to assume that it is because it's a very straightforward method, and you can write dot contains in terms of index of, so we'll just assume that for now. Okay, so we want to say if let's see, cur dot contains priv, if it does not contain the previous, then we return false. Otherwise, if we get through the whole loop and that condition is never true, then we return true. Okay, so let's just go through this very quickly. So priv is 2, cur is TOO2, and if cur does not contain priv, if 2 does not contain 2, which it does, so we keep going. Now we say stool and 2 TOO. So if cur does not contain priv, stool does contain 2, so we go to the next one. Then we go here and we say if cur does not contain priv, if tools does not contain stool, which it does not, so we return false. Okay, and then we can trivially do the same thing for this one. Okay, isWordChain. Yep. All right, let's go. B. Write the createList method, which creates and returns an array list of strings. The method identifies strings in the word list that start with target and returns a new array list containing each identified string, without the starting occurrence of target. Elements must appear in the return list in the same order as they appear in word list. Okay, let's see. Consider an example where word list contains these. So it just creates Okay. So in this case, with a create list of cat, it removes catch because it starts with, or well, it doesn't remove catch. It just removes the string that it's like. It removes the prefix of the string. Okay. Right. So Bobcat. Let's see. Containing each identified string without the starting occurrence. Okay, so since this one doesn't start with cat, it's not there. But here, cat, this does start with cat, so we just return this, or we insert that into the list. Cat starts with cat, but then that just gets us the empty string, which is fine. And then this one does not start with cat, so we don't include it. Okay, so this is also pretty straightforward. Public array list of string create list, and we know that we need a new array list. We'll just call it res equals new array list. And a good strategy that I always tell my students is to just write the signature, obviously, and then write the thing that you're creating and then return it. This can at least get you 1 or 2 points. If you have no idea how to do this, which would be a little disappointing if so, but if you did, and you just wrote something like this, I'm pretty sure this would get you at least 1 or 2 points. At least that's what my APCSA teacher told me eons ago when I took the exam. Okay? Alright, so what do? We just need to loop over each string in the list, and this time we'll actually use the enhanced for loop. So let's do for every string in this .word list. So first off, if s and we're just going to use starts with, because again you could write this in terms of index of, and that would be very simple. But yeah, so if s starts with target, then we want to create a new string without target at the front. So how do we do that? Well, if, for example, we have catch a cat, not catch a cat, like I catch-a cat, I think that's what I said before. So this starts with cat. So we need to retrieve the substring from character 3 up to the end. So it's actually just the index of the length of the target string, which you know is guaranteed to exist because of, like, if it starts with the target string, then there has to be at least a string of length target inside of s. So this won't go out of bounds. Okay, so we want to do res dot add, and then s dot substring target dot length. Okay, and then otherwise, if it doesn't start with it, then we just don't do anything. So actually, we don't even need an else branch. We can just have an if. Okay, so if it doesn't start with the target, then we don't do anything, and we just return res. Okay. Do we need to use isWordChain? Doesn't look like it. Usually when you write two methods, one of them has to be used in the other, but it doesn't say so. But I'm wondering if that would make it easier. No, I think they're unrelated. Okay, that's fine. That's fine. Okay, we're done. All right, so problem 4. All right, this question involves a path through a two-dimensional array of integers where the path is based on the value of elements in the array. When an element of the 2D array is accessed, the first index is used to specify the row, and the second index is to specify the column. Of course, The following location class represents a row and column position in the 2D array. Okay, pretty straightforward. The following grid path class contains the 2D array and methods to use to determine a path through the array. Oh, okay, that's pretty interesting. You will write two methods of the grid path class. Okay, so that's initialized. Okay, returns the location representing a neighbor of the grid element at row and column as described in part A. Okay, so let's just go here. All right. Write the getNextLoc method, which returns a location object that represents the smaller of the two neighbors of the grid element at row and col according to the following rules. The two neighbors that are considered are the element below the given element and the element to the right of the given element if they exist. Okay, that's fine. If both neighbors exist, the location of the neighbor with the smaller value is returned. Two neighbors will always have distinct, different values. If only one neighbor exists, the location of the existing neighbor is returned. Okay. So in this case, okay, let's just go through these examples. Right. So get next location. So we get the location. We get either 11 or 3. So because they both exist, we return, what does it say, the smaller of the two? The smaller value is returned. So we return a location with row 0, column 1. Okay, that's not too bad. 1, 3, so row 1, column 3. So we do 15 or 16, and it'd be 15 of course, so we return 2, 3. Yep. This would return, so row 2, column 4 is either 1 or null, but because this doesn't exist, it would return the 1. Okay, and then for this one, returns the neighbor to the right. So 4, 3. 4, 3 would be 6, given that it has no neighbor below. Okay, but what? Oh, okay, here we go. In the example, the getNextLoc will never be called with 4, 4, as that would violate the precondition of the method. Okay, so that's not too bad. Okay, and here's the information for the class. That's actually very helpful. Okay, so this isn't too bad. Public location getNextLoc int row int col. So we need to first see. Let's see. We first need to determine if the bounds are like we need to determine if this is in bounds, right? So if both locations exist, or rather, so if row is less than this dot grid dot length minus 1 and col is less than this dot grid at 0 dot length minus 1, then both elements exist. Right? So if we do, so what's the number of rows here? It would be 5. And actually, I'm curious. It doesn't say if it's a square, so I guess we can't assume that. Okay, that's fine. Right, so this is really just a case analysis on two things. So we have, so if there are two neighbors, then the above thing, this condition right here must be true, because that means that since our, let's do this, int num rows is equal to this dot grid dot length, and int num cols is equal to this dot grid at 0 dot length. Okay. So in this case, let's let's say we're doing 4, 3. So row 4, column 3. So in this case, 4 is not less than, so this dot grid dot length minus 1. So that means that this element does not exist. So like basically anything from this square to this square, or this location rather, will always have both neighbors. If it's on the last row or the last column, then one of them will not exist. And we can actually check that. So let's first do the two neighbors case. So if row is less than num rows minus 1 and call is less than num calls minus 1, then we need to do what? We need to get the location to the right of it, or rather get the value to the right of it. So val right is equal to this dot grid at what? So row and then call plus 1, because we're going from this column to this column, right? So in the case of 15, we go from column 3 to column 4. And if we're doing val below, we do this dot grid at row plus 1 and call, because we'd go from, let's say, row 2 down to row 3 if we're going from 15 to 19. Okay? So now we just say if val below is less than val right, then we just return a new location of these values. So it would be row plus 1 and call. Otherwise, so like it said, these will always be distinct. So we don't care about whether it's equal to. Like we could have a case that says if val right is less than val below, and then have an else case when they're equal, but that will never happen. So let's just not even consider it. So return new location of row and call plus 1. Okay. All right. Right. So now we have. Let's actually move this comment to right there. So now we need to say if there is one neighbor. So we'll break this up into two cases. If there's one neighbor below, then that means that call is equal to num calls minus 1. Right? And then let's say if row is equal to num rows minus 1, so this will be the case of if there is one neighbor to the right. So in this case, it'll always just be that location. So we'll do row plus 1 and call, because there's one neighbor below, then there has to be one extra row below it. But here, then there must be at least one column to its right. So we'll do return new location of row and call plus 1. And then just for completeness sake, because it won't compile without it, we'll just do return null. I'm pretty sure you wouldn't need that to get the points for this, because it said it would violate the precondition of the method. You know, this wouldn't compile without this here, because there's still the possibility of you passing in something like 4, 4. Now it violates the precondition, yes, but Java would still say, oh no, you gotta cover everything, so we're gonna cover everything just to get it to compile. Alright, that one wasn't too bad. Just a little bit of case analysis and making sure you don't go out of bounds. No need for any loops or anything like that. Alright. B. Write the sumPath method, which returns the sum of all paths. The sum of all values on a path in grid. The path begins with the element at a row call and is determined by successive calls to get next location. The path ends when the element in the last row in the last column is reached. Okay, so we go from 1, 1 to 3 to 2 to 9 to 4. Oh, okay, this is very straightforward. Okay. Yeah, so we have to use getNextLoc to get full credit. Okay. So this is actually, I think this is very simple. Int row and call. So what is so we could do this recursively, right? And actually, I think we will do it recursively. So if row is equal to this dot, so we don't actually have variables to keep, like we don't have the num rows and num call variables anymore. So we'll just do this. So if it equals this, we'll just move it down here. If call is equal to this dot grid at 0 dot length. So our base case is when we've actually reached the last cell. If we reach the bottom right, then what do we do? We return the value at that cell. So this dot grid at row call. Sorry, this should be -1. let's not screw up when we're almost there. Otherwise, we can do the following. We can get the location of the next and say get next lock. So you don't actually need this dot in this case, no pun intended, I guess. But I do it because I think it's always helpful to prefix methods, instance methods with this, and the same thing for instance variables. Okay, so I always do that. Okay. So now we're going to pass in row and call, and then we're going to do. So we're going to take the sum of that location. So int val is equal to this dot grid at next dot get row and next dot get call, and then we're going to do return val plus sumPath. Actually, whoa, hold on, we're getting ahead of ourselves. So actually, wait a minute, no. So we actually shouldn't do this. So we should just return 0 here, because in this case we're going to get the next location. We're going to get the sum or the value of the current cell, and then we're going to recurse on the next location. Okay. So we'll get the value of the current cell. Then we'll do Then we'll do like the value plus the result of recursively calling. That. Okay, so let's see what that actually looks like. So in this case we call 1, 1. So we're going to do 3 plus the result of calling this on 2, 1, which would be 2 plus the result of calling it on 2, 2, which would be 9 plus the result of calling it on 2, 3, which would be 4 plus the result of calling it on 2, 4, which would be 0 plus the result of calling it on 3, 4, which would be well, okay, so wait a minute. So actually, so we'd be well, actually, no. This would be return this dot grid at row call, because we'd reached the bottom right corner, which would be the base case. So we'd just return the value at that, but without making any further recursive calls. So because we would never call this on the base case. We could only call this when we're anywhere but the base case. So here we'd be like 0 plus the result of calling it on 3, 4, which would then get us into here, which would mean we return 1. Then when the recursion unwinds, we're going to get 1 plus 0 plus 4 plus 9 plus 2 plus 3. Okay. That should, let's do this just out of completeness. Yeah. I think that's it. So you could do this iteratively, of course. But I did not want to. Okay. That's it. That's the AP-CSA FRQs for 2024. We did it in, when did I start this? An hour 30, I think it was. What did it say? An hour and 30. So we did it in just under an hour. And that was with all of the explanations and whatnot. Okay. So I'm going to pause the video for just a second. I'm going to take all this code, put it into it. So like this is what I would submit to the College Board. So like, okay. So these 4 files, I haven't compiled them, of course, haven't, anything like that. Now I'm going to say like, so I can't change them at this point, and I'm going to throw them into IntelliJ, and we're going to see if they work. Alright, so I will be right back. Alright, we're back. So I was just checking all of the problems to make sure that they work fine in IntelliJ. Unfortunately, problem 1 has some randomness to it, so I can't really test it. But I'm willing to bet that this is fine. Yeah, I mean, I don't see why this wouldn't work. But the others, I wrote some test cases, basically just using JUnit, and these are all just the test cases that they provide for you. So if they pass these, they're probably fine. And just to show you that they work, all these tests pass. Word checker. So for some of these, I did have to like I had to write the constructor for this to receive a list of, or an array of words. Just making the test cases easier. But as you can see, all the code is the same as the code that I did in the text editor. You can go back and verify it yourself if you wish. I'll just scroll through here just to show you that nothing has been changed. All of these pass just fine. Grid path, so just scroll through it again, everything is the same. Location, I literally just copied this. I did have to add the dot equals. I didn't have to add the hash code method, but I did need to override dot equals just so the assertions would work. But other than that, everything works fine. So these are just the grids that they give you. This is the path they give you, and everything works as expected. Alright, so hope you found this interesting and helpful, and if you have any questions, you can feel free to leave a comment. Alright, thanks.